Hello, everyone. Good morning, good afternoon, good evening, based on your location. We hope you've had a good day and you, as well as your family and loved ones, are doing well. On behalf of AIOUG, I would like to welcome you for our weekly webinar series. At AIOUG, that is All India Oracle Users Group, we try and bring experts from all over the globe to help our community learn and grow. And today, we are excited to have Kim Berg Hansen from Denmark here with us to talk all about NLS character sets and collation and how to use them efficiently to make our lives simpler. Kim is an Oracle Ace director and a SQL quiz master at Oracle Dev Gym. He shares his experience and knowledge by writing, blogging, presenting, and has written the quite famous book. You've probably heard about it, Practical Oracle SQL. Outside the coding world, Kim is married, he loves to cook, and very interestingly is a card-carrying member of the Danish Beer Enthusiasts Association. We are really looking forward to learn new things from Kim today. But before I hand off, I would like to remind you a few things. The presentation will be shared. The presentation will be shared with the registered participants. For all your questions and answers, there's a Q&A panel at the bottom of the screen. Please use that and we will take the questions. Also, an important point, we really request you to take a screenshot of this, take a selfie, we call it a virtual selfie, and tweet about this. Use this especially to thank Kim for his time. You can use the hashtags, #AIOUG webinar, #AIOUG virtual selfie, and tag Kim. You can see his, you will be able to see his handle in the next slide, but tag him and please thank him for his time. So with that, I would like to hand off the session to him. Could you kindly share your screen, Kim?
Yes, thanks a lot for
you should be able to
introduction.
Share your screen.
That should be possible.
Yes.
Here, voila. So, thank you a lot for having me as a speaker at your webinar series. And the talk today is when 7-bit ASCII ain't enough. So let's dive right down to it, just as soon as I go like this. I've already been introduced, so we go quickly. Just please, if you're not using the developer gym, devgym.oracle.com, do so. It's a fabulous way to either learn new stuff or refresh your memory about either SQL or PL/SQL or database design. My book was mentioned. You can download these slides afterwards and look further into that. I'm in the ACE director. I'm in the ACE program as ACE director. And this is some data about the company Trevadis, where I work, a Swiss-based company. So quickly on to the agenda for today. These are the things that I'll go through. And the first point is the most important. I'm going to demonstrate that. The rest will be talk and presentation. But the first point, you really need to know that. And afterwards, if you don't have time for any more, you can decide if you feel if it's interesting, the rest of it. But stick around at least for the demo, where I'll show how to corrupt your database. The circumstances leading to invalid characters in the database. Yes, there is a wrong way to do it, and it's quite easy to fall into that trap. I'm going to do that with a demonstration. So I have a little script here, a file. I'm going to cut and paste from this one because I'm going to execute it in 2 different sessions. I have both a Windows command prompt ready that I'm going to use a little bit, And then I have a Linux session using MobaXterm, but you could use PuTTY or whatever. It's just demonstrating different environments. So let's start off by creating a little table. A quite simple table. Table movies has a title, and then it has a column where I can see which session inserted this. I'm going to use that to insert into this table from different environments. Just let's check this database. This happens to be a 19C database, but all that I'm saying here is relevant for basically since version whatever, 7 or 6 or something. So this database is then with a character set AL32 UTF-8 as the database character set. So basically one would think everything is good, UTF-8, we can store anything. Well, yes, we can store any character, but we have to store it encoded in UTF-8. And that is possible to get around that and store it in different encodings, as you'll see. So let's look into that Linux session. I've now done what the preparation, so I'm going to exit and set up a session just to show you that OS I have locale is English, US, and UTF-8. And what I'm going to do next is to set the NLS lang environment variable to match the OS settings. That's the good way. Then I'm going to start SQL+ and insert a row. So let's do SQL+ and insert this one row with a movie title, Jesus Nuestro Señor, Jesus our Lord. And let's view that. So what we can see here when I view this is that we, of course, see our title that we just inserted. I see that I inserted on a Linux session, that OS was UTF-8, and NLS lang was also UTF-8. Using length B and length, I can see how many characters. There are 20 characters here, but there are 22 bytes, which I use length B to show me. And if I dump those bytes, what I can see is that the two special characters, the U and the N with some diacritics above them, they are each 2-byte characters. This is the U and this is the N. So it's stored in the encoding that's called UTF-8. Everything is fine so far. Let's get out of that session. So just to, in that session, everything was the same. The database was UTF-8, the NLS lang was UTF-8, and the operating system also used UTF-8. Let's try and go to a completely different session, a Windows session, and see what this command prompt is using. It's using a code page 437. I'll talk a little bit more about all these different code pages and so on later. In command prompt in DOS. We can also set the NLS lang. And here I now set that with a setting that matches the operating system again, America, but the encoding part I'm now using US8 PC 437. And then I need myself a SQL plus here on this side. And I insert one more row into movies with the same title, but just with a different I just happened to do it twice. Oh well, no problem. With a different setting here. So if I view those rows, I have the one I inserted at Linux. I have the one inserted, the two inserted here by my Windows session. In the database, they are completely identical. The dump here shows no difference whatsoever. They are all the same. Same bytes, same characters. The thing is, this DOS window, it's not showing UTF-8 characters. It's showing ASCII 437 characters. So what happens? What happens is that the client looks at the NLS lang and sees, aha, client side, I have a different code page than in the database. So when I send bytes to the database, they will be converted automatically to UTF-8. When I retrieve bytes, like here in the select, and I show them, they will be converted from UTF-8 back to the PC 437 code page. So everything is happy here. I'm converting the stuff back and forth. And in the database, it's correct. So let's go back to the Linux session again. We have exited the SQL+. We had our, just to repeat, that the language here in the OS, the character set is UTF-8. But now let's say we do not have the NLS lang environment set. So if I do, and it's not there. So that would be a mistake by someone, forgetting to have the NLS lang setting. So let's try to see what happens now when we insert Jesus Nuestro Señor once more. Well, it accepted it, no problems. And then we start to look at the data once again. Now it looks more mysterious. The thing to note here is that the first three rows, the ones we inserted correctly, they are in the database. The bytes inside the database, they have not changed, but they look wrong in the output. They are not wrong, they just look wrong. This one suddenly has the one we just inserted. That's the one we just inserted. Suddenly shows 2 question marks. And for some reason, there are 30 bytes stored in the database. Now, what is going on here? Let's examine that a little bit. First, we can have a small check just to see user in language, American America, AL32 UTF-8, everything looks okay. Yes, but what you see there is the AL32 UTF-8, that's the database encoding. To get what the database believes the session client encoding is, we use this query, selecting from $connect session connect info. And we have the client character set showing US7 ASCII. Because we have not set NLS lang out on the OS side, the database thinks, I don't know, I'll have to use the lowest common denominator, US7 ASCII. That's probably what will come. So what happened at our insert? When we sent these bytes in the insert, the OS actually was sending UTF-8. So the OS was actually sending these 22 bytes with the 2-byte characters here and here. But the database believed that it was sending US7 ASCII. So when it got a byte 195 with the 8-bit set, it said, oh, I'm getting something invalid. I'm not getting US7-bit ASCII. So when it gets something invalid that it cannot convert, because it expects to convert US7 ASCII to UTF-8, it got something it cannot convert. Therefore, it will place instead a character that indicates this. So it will use a diamond shape with a question mark within it. That is a 3-byte UTF-8 character. That's this 239.191.189. Those 3 bytes, that's UTF-8 for a question mark inside a diamond shape. So that's what it inserted when it got this byte. Then it got another byte and inserted the same thing. Got another byte down here that also wasn't 7-bit ASCII. So it inserted this question mark character once again and once again. So it inserted 4 times this character that indicates bad data. And therefore the total here became 30 bytes. Now I queried this and it's going to output it. And in the output, it also wants to convert. So it wants to convert from this 3-byte UTF-8 character to 7-bit ASCII. In 7-bit ASCII, I don't have such a weird character question mark within the diamond shape. So it's going to be converted just to a question mark. And that's the same that happens up here. These 2 bytes, they are the UTF-8 character for N with a tilde above it. It cannot be converted to US 7-bit ASCII, so it outputs a question mark. This is UTF-8 for the U with a accent diacritic above it. For some reason, it says, I'm going to just convert it to a regular U. Why they are not doing the same here, just convert it to a regular N, I don't know. There's probably a reason, but what's happening here is the UTF-8 that's stored in the database is converted to US 7-bit ASCII, and therefore we see something that looks wrong. And that's all because the NLS lang out in the OS was not set. But everything that's stored in the database is still correct UTF-8 encoded. Let's try and see if we cannot do something worse than that. Let's change our OS environment. And to make sure, I also need then to change the setting of my MOBA Xterm to match that. I'm now using ISO 8859-1. And that is what I have set my locale in the operating system to. The locale here, Danish, Denmark, ISO 8859-1. Good. I'm now going to set my NLS lang, but I'm going to make a mistake that I have seen quite a few people do. I'm going to set my NLS lang not to match my OS session, but I'm setting it to the setting of the database. Some people think that NLS lang must be set to the same as the database. Let's try and see what happens when we do that. We look at our session client encoding. So the database believes NLS lang. We have told the database that our client is encoding in AL32 UTF-8. It's not. It's encoding in ISO 8859-1. But we have told the database this. So what happens when I insert a row? With Jesus Nuestro Señor. Uh-oh. I cannot even insert it. And the error message seems like it's doesn't make sense. Here's my starting quote, and down here's my ending quote. What's happening? That one's a bit tricky. But what actually happens here is that the database is lazy. It says the client is sending UTF-8. And I need to store UTF-8 in the database. Fine, I don't need to convert. I'm just going to take unchanged every byte that comes from the client and use it as is. No check, no conversion, no nothing. Just pass it along. But in ISO 8859-1, this character, that's a single byte character. And the byte value of that single byte happens to start with 111110. And in UTF-8 encoding, whenever such a character, such a byte is met, that means by definition in the encoding that it's the first byte of a 4-byte character. So the database thinks, these 4 bytes, they are one 4-byte character, which means the database thinks this ending quote is part of a single 4-byte character. Therefore, it believes quoted string not properly terminated. And all because of a wrong NLS lang setting. Just let's examine a little bit more. Let's say Jesus our Lords, make it multiple gods, and insert Jesus nuestro señores and see what happens. Because now the database will think these 4 is a 1-byte character, a 4-byte character. And it registers now, here's the end. So let's view these rows. What we see now is that, it looks like this one that we inserted is correct. But all of these that were correct UTF-8 looks like they are bad. When we examine the bytes stored in the database, however, this is correct. And this one down here is actually also correct encoded UTF-8. But what happens when we query them is that, again, no conversion takes place. So this 2-byte UTF-8 character will be shown as whatever character is 195 in ISO 8859-1 and whatever character is 186 in ISO 8859-1. And down here, those large 3-byte characters are shown terribly. And also, it's been shoved too far to the side because the database believes that it would have been output only as 20 characters, not these 30. Down here, on the other hand, we have now in the database a byte 250. That is the normal ASCII value in ISO 8859-1 for this character. So when I output it now to my session, it looks good. But in reality, this byte and this byte, these two are not valid in the UTF-8 encoding. Now we have corrupt string data in the database. These 2 bytes are bad. Let's go out of the bad session and change the locale back to a proper UTF-8 and change our terminal as well. So translation and get that to UTF-8 as well. So it's now as it should be, checking in US UTF-8, set the NLS lang to the same, start SQL plus again. And let's just check client character set, AL32 UTF-8. So now we are back like the very first session I showed. And I query the data. Where am I? Let's just do it once more. Yes. And no. And let's didn't I get that's better. This is the correct. What we can see now when I have my terminal set to showing UTF-8 also, that these were the ones I inserted correctly and chose correctly. This was the one I inserted while the database believed it to be US 7-bit ASCII, and I am output these characters that are question mark within a diamond shape. And down here, this one and this one are bytes that do not exist in UTF-8 encoding. It's completely invalid. So, well, I'm getting garbage. I'm getting whatever it has decided to show instead of garbage. Because it really has no way of showing it because it's totally corrupt UTF-8 encoding. That concludes the demo. You have seen now how we can, by a quite simple mistake, set the NLS lang to the database character set instead of the client character set, and we can corrupt the strings inside the database. Going to the presentation now, the next pages of the presentation, that's exactly what I just demoed. So when you download the presentation, here's everything that I have just said in the last half hour. And the real lesson for you is that the client NLS lang should match the OS locale encode page. If we have the Charset OS that's different from the NLS lang, but NLS lang is the same as the DB, the wrong bytes are not converted. And if the character set OS is different from the NLS lang, but it's different from the database, conversion then happens to from the wrong character set, and you will end up with complete garbage. This is that one thing you must learn from this session. The rest is a bonus. So having said all I really wanted to say, I'm now going to go over some of the details, why things are like they are and what is the background for what happened, and some more NLS settings and sortings and collations. Because we have progressed, we are no longer using stone for encoding. Encoding is a tricky thing because what can we do? Like we can write letters, SOS on a piece of paper, or we can talk it, or we can use Morse code. When we get to digital, well, we can use ones and zeros. We have to store some bits. But we have to kind of agree on how it means. Like here we have example with 7-bit ASCII, 7-bit ASCII, and with 8-bit ASCII. You have to agree and know in advance. Otherwise, when you get the strings of ones and zeros, you have no idea what it is. You need to know what encoding has been used. And the simplest and probably the earliest 7-bit ASCII, and that's like the basis of most encodings, also the modern ones. When that wasn't enough, we went international. They started 8-bit and had then different code pages where the upper part of the code bit, all of those bytes with a 1 in the 8th bit, could be in different code pages. I demonstrated code page 437, United States. If it's code page 865 Nordic, there are just a few differences from the United States one. But if you're Russian, there's a lot of differences. So 8A can mean different things depending on what code page you're using. Then along came standardization, because the code pages was like MS-DOS thing. So standardization, ISO 8859 made different international standard code pages, 16 different. Well, number 12 isn't really, because that was a aborted attempt. ISO 8859-1, Latin 1, it's also known as, that used to be the most popular one for international web pages before UTF-8. MS Windows, well, they made their own ANSI code pages based on the ISO 8859. Windows 1252, that's standard English Windows, except that where the ISO has left unused characters between 80 and 9F hex, MS Windows use them for smart quotes and other things. And that can also be a mistake, that you have a database that's ISO 8859-1, but a client is sending Win1252 in, so you get some smart quotes in the database, but the database doesn't know how to do with it because they don't exist in the database encoding. There are just too many encodings, and that's just a part of them here. Unicode then. Unicode can rescue everything, right? We don't need to worry about all the encodings. Unicode, we can encode any character. Alphabets, formulas, symbols, emoji, basically whatever you can think of, there's a Unicode code point for it, Unicode character. So the characters, they are assigned a code point, but that's not the entire picture, because we still need to have that encoded. And when we encode it, we can choose between different encodings again. Because, well, beginning of Unicode, it was just 2 bytes. Then it grew, so Unicode, we now have up to 4 bytes. If we stored everything in UTF-32, which is 4 bytes for every character, well, most English text would suddenly be 4 times larger. And therefore, some smart guy invented like UTF-8, which is now the most popular encoding. And what that means is that all of the 7-bit ASCII can still be stored just in a single byte. Other characters will use either 2 or 3 or 4 bytes. And the most common characters then have the lowest byte count. so that they don't use quite so much space. And you can see here, like a regular E is 1 byte, and other characters are 2 bytes, and so on. And then we are actually with the problem that gave us an error when we tried to insert Jesus Nuestro Señor, that the N happened to to be the same byte value as a byte that by definition is a 4-byte start of a 4-byte character. So we know all about encodings now. How do we care about those in the database? Well, the database has 2 character sets, and you kind of need to know what the database character set so that you don't mistake that guy for being impolite. He is actually using encoding in Tibetan, and therefore he's polite. The database character set. You choose that at database creation time, and it's used for all the data in char, varchar2, club, and long. It's also used for identifiers and source code. And from version 12.2, the default, when you install a database and you don't select anything different, then it's AL32 UTF-8. Before that, it was a ISO 8859-1, I believe. And this database character set, you normally can never change it, because once you have encoded data in the database, they are there and they are encoded. You do have a possibility. There's a tool, I'll get to that at the end. There's a tool to convert from a single byte character set to UTF-8. Now, since the database character set also is used for identifiers and source code, in principle, when the database character set is UTF-8, you could use emoji in your object names or source code if you want. I would normally recommend that don't use something that's multi-byte for identifiers and source code in general. The other character set I mentioned, the national character set, that used to be the way to support Unicode. Then you would use the data types nchar, nvarchar2, and nclub. And those you would then be encoded in the national character set, which then could support multi-byte data. If you are setting your database character set, like is the default nowadays, to UTF-8, then you don't really need nchar, nvarchar2, and nclub and the national character set. You may have a very, very weird situation where you need to support both UTF-8 and UTF-16. Then you could put UTF-16 in the nchar, nvarchar2, but I cannot really think of a practical use case. For multi-tenant from version 12.2, normally you would guess that the CDB and all the PDBs should be the same character set. And that is what I still would recommend. But you do have a possibility that if the CDB is UTF-8, you can plug in PDBs of different character sets. Or if you have like a CDB that is MS-Win 1252, you can also plug in a PDB that's ISO 8859 P1, because it's a subset of the Win 1252. But after being plugged in, it will be automatically changed to the CDB character set. It will not stay ISO 8859. You saw in the demo that I used length and length B. That's because we have some length semantics, byte versus char. So how to spot the multibyte. Length is not just length. If we have ISO 8859, senior, that's 5 characters, but it's also 5 bytes. If we have UTF-8, senior is still 5 characters, but it's 6 bytes. So if you make a table, if you noticed, if I just go back here, create table, I did varchar 230 char. By adding this char, I specify that this maximum length is to be measured in characters, not in bytes. I can choose between either char or byte. But if I'm not putting anything, if I'm just doing like I used to do, varchar 230 and not putting anything, then when the column is created, it looks at the NLS length semantics of my session and uses either byte or char at that point. You could set NLS length semantics to char for your database. That could be a bit dangerous because it is possible that things you need to install in sys or system patches, things like that, are expecting byte semantics because that's the default. Therefore, normally put char explicit in your own DDL in your create table statements, or if you need it, also your session NLS length semantics to char before you execute your create table. So like here, I can use title varchar to 100 bytes, then I can store up to 100 bytes. I can do varchar to 100 char. If the database character set then is UTF-8, that means it can be up to 400 bytes. If I happen to have a very, very weird string that's 104 byte characters. And as I said, if I just do it without specifying something, it will pick NLS length semantics at the time of creation. So just to note that if I do 4000 char, that does not mean that I can have more than 4000 bytes if I'm using a standard string size. 4000 char doesn't magically mean that I can have 16,000 bytes. The only way to do that is to use the max string size set to extended. Then your limit will be 32 kilobytes, but still measured in bytes. If I say 32,000 chars, it's still bytes. And you saw me use length, and that returns then the length that's measured in characters using the input charset. So if you use an ISO 8859, a single byte character set, you get the length in regular characters, and it'll be the same as the length in bytes. But if you have UTF-8, length will give you the character count, no matter if some of the characters are multi-byte characters. To get the length in bytes, you would then need length B. And the other three, length C, length 2, and length 4, measures in specific ways Unicode complete characters, uses 2, uses 4. The use cases for those are very specific. Length and length B are the most practical ones. So moving on to the NLS settings. I've talked about NLS length semantics and other settings, but there are several NLS settings for those of us who cannot just use good old US 7-bit ASCII. NLS parameters can be on the database level, the instance level, and the session level. And they can be queried with on NLS underscore database instance session underscore parameters. And then there's also $NLS parameters. If I query them all together, I can see here what are the settings on the database, on the instance level, and on my session level. I have not here changed the session compared to the database. $NLS value is kind of like current NLS settings, meaning that where something is applicable from session values, that's shown in $NLS value. Those that are not relevant from session level, it will be the database value that is shown. Just for fun, note NLS time format. It states it's currently for internal purposes only. Let's see if at some point in the future we get a time data type. So the session NLS setting, as we've seen in the demo, when we connect the session NLS settings defaults to values that are derived from NLS lang. And that's language, territory, and character set. Territory gives derived values for a lot of the settings. Like Denmark, then it knows, currency is Danish kroner, calendar is Gregorian, date time formats use the date in front of the month, numeric characters, we use comma for the decimal separator, and so on. And that can be overruled with also session. In Windows, you'll find that NLS lang in your register when you have installed an Oracle client. And upon installation time, it'll look at your Windows setup and pick NLS lang to match that window locale setup. And if that doesn't fit your client program, the wish that you have there, you might need to have to go in to change it here. Or you might choose to leave it as is in registry and overrule it in Windows environment variable, like I did. Linux, you would do the Linux, the environment variable thing. You don't have the register there. But it's important to set these. And there's a view that can give you what are the valid values that you can use. What are the supported values by the database for character set, for language, for sort, for territory. And when you view this view, there's an is deprecated. So there are some that they are there because of backwards compatibility, but you shouldn't use them anymore. And all of these NLS things can also be used for linguistic sorting and matching. So one of the parameters is NLS underscore sort, which can be binary, then it's sorted by the binary values, or it can be a linguistic collation. and it defaults to a derived value based from the NLS language. You do have the possibility to choose the collation, like for example, Danish, but each of the collations support that you can append _CI for case insensitive or _AI for accent insensitive. And one of the things to note with this is that the linguistic collation ignores punctuation marks. We had a problem at my previous work where a lot of the keys were not integer keys, they were varchar2 keys. Maybe a bad design mistake, but that was what it was. As keys, they should be sorted binary. But the application would set NLS language, and that would mean a derived NLS sort, and therefore the key columns would be sorted linguistically rather than binary. And what we did was that we made a after logon trigger to alter session set NLS sort equal binary to make sure that we did not derive sorting from NLS language. And then those fewer places where we needed a linguistic sorting, non-key columns, we would explicitly use the function NLS sort. I'll get back to that one in a little while. There's an alternative to doing this when you're 12.2 or newer, and I'll talk about that shortly. NLS sort has a companion parameter, NLS comp. How it should do comparison of two strings. That can be binary or it can be linguistic. Linguistic means it then uses the collation specified in NLS sort. It can be ANSI, but that's just for backwards compatibility. Interesting thing to note is when you set NLS comp to linguistic so that you compare using the collation, distinct then can return indeterminate output. For example, German, the NLS sort X German, and I do case insensitive. In German, there's this letter, that's a lowercase s, that's one letter. In uppercase, it doesn't exist as one letter, it is two uppercase s's. But with this NLS sort and NLS comp linguistic, they are considered to be identical, these two. So distinct would say, if I have these in two different rows, distinct would just output one of them, but which one would be indeterminate? It would output either the first one here or the second, depending on probably whichever one it first finds in whatever access way that the optimizer has chosen. We have a function NLS sort without underscore, and what that returns is just a string of bytes. And that can be used typically in an order by. So you can order by NLS sort and give a collation there. You can do a function-based index with this, and optimizer can use that for sessions where you have an NLS sort parameter. Using the NLS sort and order by, for example, in Danish, we have a special letter. That's an A with a little circle above it called O. But a double A is actually the same. That was how it was in the old days. So when I sort with Danish M case insensitive collation, the double A's are sorted down here at the end of the alphabet together with this special letter. So that's actually nice that it supports such special things like we Danes do in our weird language. There are other functions, NLS upper, NLS lower, NLS init cap, that handle these special things. Like, for example, Dutch, if you do NLS init cap, IDA, that's a single character, so it would turn this into IDA. Both of those would be uppercase for init cap. And that's a special difference between these two. I explained that one. Let's go move a little faster. And this NLS sort, NLS comp, that's very nice. In 12.2, we can do data-bound collation and make life a little more simple for some things at least. It needs that you have max string size set to extended. And what it enables you to do is, instead of having to put all this NLS sort different places or make sure your session NLS sort is what you want, you can define down on a column level that this column should be collated Danish. And you can define that collation in the select statement itself as an operator collate. You can define it on column level on the table or view, or in the function call that it collates something different. The default for this is a pseudo collation. It's called using NLS sort. And that means behave like we used to do with using NLS sort and NLS comp. So the default is nothing has changed. But if you set something with a collate operator to a specific collation, you overrule this default. The valid collations are the same as you can use in an NLS sort. So the problem I had before at our previous work, we could have solved it in 12.2 or newer this way. Our key column, we don't put any collate on it. Our city column, we put it to collate Danish MCI. And then on the table, default collation binary, meaning that this one where I didn't set anything, it will get binary collation. It will use that default collation when the column is created. You cannot just change all of them in one go, but it will use them upon creation. So I insert those cities, and now if I have a session that's sorted binary, for example, I do a normal select order by city. I'm not using any NLS here, but it's output case insensitive ordered and with a special rule of Danish, because city has, that column has the collation defined specifically on the column. I can overrule it. I can do order by city collate Danish CI, which is a different Danish collation that does not use this special rule. So the double A's are now sorted as normal A's. And this can also be defined on a column in, for example, a view. This inline view here could have been a normal view also. So for example, if you have a situation where the tables in the database should use binary because your application needs that. But when users query they want it to be collated linguistically, you can define a view with collate on it and let the users query the view instead of the table. Okay, let's just skip that. Just beware here, the like operator, well, like operator obeys the collations, in string obeys the collation, but it can have little quirks, like this special Danish that if I ask for single A's, I get these. If I ask for the special letter O, I only get that one. I do not get these even though they are considered the same. If I ask for AA, I do get them, which is then weird that it doesn't go up here. So in my opinion here, there is a slight bug. So if you have special language rules in your language, it can be an idea to test if the implementation actually covers all of those rules. Yes, and then that shoots to some minutes here for talk about my last topic, and then we'll go to Q&A at the end. The last topic is the database migration assistant for Unicode, when we want to migrate to Unicode. I'm just going to talk about it. It could be a complete session all by itself. But it's a tool from Oracle. It has a GUI, like this GUI here. And what it can do is it can convert a database from single byte character set to UTF-8. And it will convert it in situ. You don't have to export the data and import them again. It can scan single byte character set databases for invalid data or for other problems that would cause trouble when you convert. And it can also be used if you have a AL32 UTF-8 database to scan it for invalid data. So for example, if I used the DMU scanning on my database now that I demonstrated that I could get corrupt data in it, the DMU would find those corrupt data and say, you have something here that's not valid UTF-8. There's some pretty good documentation on this and an FAQ that's also helpful and a troubleshooting guide, because there can go a lot of things wrong with the DMU. It's good, but there are also things less good. It is a Java GUI like this one, which you can run either on the DB server or on the client. It does not really matter much if you do it on the client, because it's not like moving all the data to client and then back. It's executing SQL, so it happens on the database anyway. You can download it either from MOS, My Oracle Support, or from OTN. It's the same that you download wherever you download it, but if you download it from My Oracle Support, it's a supported product and you can contact support if you have problems with it. When you work with it, when you want to migrate a single byte database to multi-byte, what you do is you start by scanning the database, and the DMU will report anything that cannot be converted. It will report, for example, if you have an ISO 8859 database and someone stored Windows 1252 data in it, so that you have some bytes that are invalid in ISO 8859. That means they cannot be converted, so DMU will report those. also, DMU will discover that maybe you have 4,000 bytes, but when you convert them, some of those will be multi-byte characters, so they would become too large. It also checks data dictionary and many other things. So you scan the database, get a report with a lot of errors, and then the DMU has some tools for some of those problems that it can repair them for you. It can convert your columns from byte semantics to char semantics. It can do mass replace of invalid byte values. So if you have, for example, smart quotes stored in your ISO 8859, it can replace them to regular quotes. There are several tools it can do to repair, but it cannot do everything. So what you do is you scan, check the report, repair, scan again, check the report, repair, and so on. You iteratively to do step one over and over until the scan says, yes, there are no problems. I'm able to convert everything. You have a green light. You can migrate now. Then you do the convert migrate step. And it will in principle just do updates, updating all of your data and all the character data, converting those bytes that have to be converted to multi-byte UTF-8. Updates can take quite a lot of time. So if you're in a situation where it's okay to get new row IDs, there's a parameter that can say use create table as select. And then instead of update, it will do a create table as select, which can be much faster for massive updates. After you're done, you scan the result once more and verify that everything is now correctly UTF-8. This sounds nice and easy, but there can be several issues that might block the DMU. For example, generally it will not touch data in the data dictionary, things in SYS or other Oracle supplied schemas. That means that if you, for example, have a column name or procedure parameter name, we had, for example, a procedure parameter called zurück, German, using the U with umlaut, 2 dots above it. That DMU cannot convert. Column names, procedure parameter names, they have to be 7-bit ASCII, basically, in order to work with the DMU. So that cannot be automatically repaired. You have to change your column names or code to avoid such things before DMU can move on. In source code, yes, it can handle that if you have text that is not 7-bit ASCII, but has O umlaut, for example. Most of the source code is okay. DMU can handle that. But like an object type specification, for some reason, the type spec itself, if that has a comment, like we had a comment author who was the author of the code, if that was a name with a specific, nope, DMU will say, I cannot convert this database. You have to change that manually too. If you have a varchar2 attribute that's used in an object type, which is used in an object table or a queue, and you need to change that from byte to char semantics, nope, that cannot be done without dropping the table. And that could become problematic even if you do a data pump export, drop table, drop type, and then recreate everything with char semantics. because when you then want to do data pump import, the type signature, even if it's recreated with the same object ID, the type signature has changed because it's no longer a varchar 230 byte, it's a varchar 230 char. And then data pump import cannot happen. You may find yourself in a situation where you have to export the data to a flat file using like SQL Developer and then import the data again from a flat file afterwards. You also could have some situations where some of the columns after conversion would lead to an index becoming too long that it cannot fit in a block, where you then need to decide, do I really need this index, or do I need to make a table space with a larger block size to accommodate these indexes? You might have some data that won't fit any longer because it'll become too long to fit in a varchar 2 and you need to convert it to clubs. And so on. There are multiple other tiny things, variants of small issues. So the DMU is a great tool, but you may end up having, depending on your situation, so many small issues that it might be easier for you to just simply build a new database and migrate the data. But using the DMU to scan the database, even if you're not thinking about migrating, that can be a very good idea actually, because it will find if you have corrupt encoded strings in your database. And that, if you locate some columns with some bad text, that might help you to find out if some of your clients in the application are using the wrong NLS lang. And the DMU can also help you then to fix all this corrupt text if you have corrupt encoding in the database. And I want to right now thank you for your safe distance attention. And we move over to, here is a link to the presentation, link to my demo text that I used, link to a blog post by Neil Chandler and a blog post by myself. And we are now at Q&A. Let me go over. We had some questions in the Q&A itself. Let's see. First, we had one from where does it get the charset US7 ASCII, which is considered default if we do not set NLS lang at the OS level. Well, that has been decided by Oracle. If NLS lang is not set there, then we must assume the lowest possible, and that's US7 ASCII. So that's just the way it is. So the application team, then it says, should we ask the application team to match with a database NLS character set? And that's explicitly no. I think I answered that later. This question was before we got to the piece where I corrupted the data. The NLS lang should be matched to the OS so that those bytes that the OS is sending, that encoding, that the database understands that correctly and can convert if need be. One thing interesting here is sometimes you are in a situation where you need to make a report, SQL Plus script that makes a report, and you need it in a specific encoding to send to someone. When you go to that specific encoding and you want that, many people would write their scripts so that they would select using functions to convert to that character set that they should do it. It would actually be a lot easier in the script that calls the SQL+, in that shell script, set NLS lang to that encoding you want in your output. Then do the select, and it will be automatically converted to that encoding, and then set NLS back after the script is done. So NLS lang is all about client side. So next question is, which NLS setting takes precedence, client or server side? Well, when the session is created, when you connect, it will set session NLS settings, and they will be taken partly from NLS lang from the client side. Most of it will be taken from that. If it doesn't have anything there, it will take from the server side. But it will then be set as the session NLS parameters upon connection time. Then if the session, the session is free to do also session set NLS whatever setting to something. Okay, question then is whether any NLS difference can cause a query performance issue. Absolutely. Like for example, all the thing with sorting, if a sorting is linguistic due to NLS language on the setting being set, session being set, another session has binary. Those will be the same SQL ID because it's the same SQL they are executing, but they'll have two different child cursors and can be different explain plans, because the optimizer will have to consider that one of them, it might be able to use regular indexes because of the binary. The other one has to be sorted and might not be able to really use the index very well. At least it cannot use the index to sort. It'll have to do a sorting operation. So unless differences, yes, they can cause query performance issues. And that is also one of the things that as developers try and make sure that your developer session has the same NLS settings as the one where your code will be executing, that environment where it will be executing, so that you can trust your explain plans more. Yep. If you have a global application with names as all the different languages, recommended character set, a database creation, that would be AL32 UTF-8, I would say. And that is now the default anyway from Oracle. So going forward, AL32 UTF-8 would be the recommended database character set. In a multi-tenant database, can you get problems if you plug databases with different character sets? I've answered that one along the way. plugging is only possible if it's a compatible character set. And if you do multi-tenant and you need pluggable to plug in different character sets, then do the have the container be AL32 UTF-8. Right, I think that answered what was in the question and answer. So let me
Yes, Kim.
check in the chat box if there's anything more. Yeah, there's one, can I watch it later? And I assume there'll be a recording on the YouTube channel at some point. One helpfully said, you didn't change Mobi settings. Thank you. I found that out a little late. Did the terminal charset change? Yeah, that was the same. It's very good audience. They discover the mistakes I did. Where can we get this presentation? I showed links in the end there. And it will also be uploaded to the webinar, I can see, yes.
So Kim, we have one more question that reads,
Okay.
do we need to set, okay, we got it right. Do we need to set the NLS comp for any query explicitly when comparing data for performance?
So explicitly set NLS comp for query performance. Well, it's a matter of what you need for the application, really. NLS comp typically would be binary, and which is, of course, the fastest for the database to compare strings just whether the bits are the same. If you explicitly need something to be compared linguistically, when you set NLS comp on the session to linguistic, that will impact query performance, yes. Probably not a lot. It will depend on so many things. And if you have like function-based indexes on NLS, NLS upper, for example, then such things can help for performance. And NLS comp linguistic basically means that when you just do where column equal column, then that will be taken care of automatically for you, that it will compare linguistically. I think in most cases, it will be safer to leave the session to use NLS comp binary, but in the query, do where NLS upper column equal NLS upper column. And then in those NLS upper calls, you specify the language directly. And doing it that way would also ensure that when you then do an index, a function-based index on the NLS upper, the optimizer can very easily pick that one.
Thank you so much, Kim.
And I think that
done.
was the exact 1.5 hours.
Yes, absolutely. We are right on time. So again,
I spot one short difference between DMU versus CS scan. I really cannot say. I have never used CS scan. I'm sorry, I don't know.
Actually, I can just add to that point. The CS scan is no longer supported. With the later versions, it's all DMU.
In that case,
yeah.
Yes.
Right. Thank you so much, Kim. Again, I mean, for your time.
You're welcome.
This has been an absolutely great session. I've learned so many insights, little things that I always wondered about. That made sense. Okay. So before we close, I would again request everybody to fill, you can see the speaker feedback. You can just scan the QR code and you will be able to fill in the speaker survey. We appreciate the feedback. And of course, you can use this form for any more questions if you have for Kim. We'll pass it along and we'll publish the answers on our portal. Again, a request for you to thank him for his time that he spared for us. He gave us some great tips and insights. Tweet, head over to LinkedIn or Facebook, Twitter, use the handle and thank him. That would be something I would request all our participants. One last thing, that if you have attended all the webinars for the month, for the calendar month, please feel free to reach out to us at the provided email ID. That's webinar@aioug.org. And you can request your participation certificate. Now, before I close, I have just one more announcement. This is continuing the series of our formidable webinars. Next in our almost star-studded lineup after Kim, we have Martin Clear. So Martin will be here to talk about Oracle database performance on August 5th. This is where he will discuss wait events, AWR, stats pack, ASH indexes, stats, and optimizers. So this is going to be an entertaining sessions for those of you who've attended Martin's sessions before. And it's for professionals who want to learn more about performance analysis. Again, the week after, we have Mike Dietrich on August 12th, where he will talk about database upgrades, including plugging in CDB, plugging in databases into CDB, auto upgrades, the various settings with auto upgrades that you can tweak. This session will also contain a live demo. So with everybody wanting to move off from the end of life databases, there's perhaps never been a better time to learn about upgrading your databases. And the last session, or rather what from the lineup that we have already published, the following week, we'll have on August 19th, we'll have the brilliant Christian Antogini, who would be here to talk about shareable cursors. That is everything about cursors, hard parsing, library cache, bind variable peaking, adaptive cursor sharing, optimizer, and yes, statistics feedback. So how you can utilize all these things to reap performance benefits. That's everything you probably want to hear or probably want to learn. So we've got some really great sessions coming up. So this is what I wanted to share as well. So with that, thank you again, Kim. We're so honored to have you here and so glad about
Thank you
that.
all. It was a pleasure.
Yes, we'll close this webinar now. Thank you. Have a great day, everybody.
Enjoy your day.